The air in the valley of the great wind, nestled between rolling hills, hummed not with the roar of engines or the clang of machinery, but with a different, deeper resonance. It was the low, constant whoosh of thousands upon thousands of elegant, towering wind turbines, their slender forms stretching towards the sky like metallic reeds, turning in silent, synchronized harmony. Their composite blades, crafted from advanced, lightweight materials honed over centuries of research into aerodynamics and structural integrity, caught the slightest breeze, translating the kinetic energy of the air into clean, renewable electricity. This energy flowed into a vast, intelligent, interconnected grid, a lattice of high-capacity power lines woven with intricate data streams, powering not just the sprawling cities scattered across the continent, but also the network of dispersed production centers, educational institutions, and critical research facilities that formed the sinews of their society. Below these silent giants, automated transport systems glided along dedicated, elevated paths and ground-level tracks. Some drew power directly from overhead cables connected to the grid, humming quietly, while others utilized advanced solid-state battery technology, sleek and efficient. This was Earth in February 2025, a world that had modernized and developed technologically along a different path. The relentless, smoke-belching engine of the Industrial Revolution is known in another history, the era defined by widespread fossil fuel use, centralized factories, and rapid resource exploitation, had simply not occurred on the same scale or pace here. The pivotal divergence point wasn't a single event, but a complex, multifaceted failure of convergence in the 18th century. In our history, scientific understanding of thermodynamics solidified. Inventors like James Watt perfected efficient steam engines, easily accessible coal and iron were exploited, and socioeconomic conditions favored labor concentration in factories, leading to mass production and rapid urbanization. In this timeline, these factors simply did not align synergistically in the key regions that drove our industrial revolution. Perhaps crucial scientific discoveries were delayed. Understanding of thermal dynamics might have progressed more slowly, without the immediate practical application that water-powered mining and textile industries provided in our history. Key inventors might have failed to perfect efficient steam engines, facing persistent technical hurdles in metallurgy or engineering precision that prevented widespread adoption beyond niche applications. Easily accessible, high-quality coal and iron ore deposits in places like the British Isles might have been less prevalent, harder to extract economically with 18th-century technology, or possessed different properties making them less suitable for early industrial processes, perhaps too sulfurous or unstable, requiring more complex extraction techniques than early technology could handle. Alternatively, or in conjunction, social or political structures might have proven more resistant to industrialization's disruptive forces. Traditional craft guilds, deeply entrenched, might have retained more influence, successfully lobbying against or simply outcompeting early, inefficient factory systems through superior skill and control over networks. Decentralized production networks, perhaps organized by merchant consortiums but relying on individual workshops or cottage industries, might have proven more resilient and adaptable. Agricultural economies, perhaps more efficiently managed or culturally entrenched, might have inhibited mass migration of labor to nascent urban centers. Governments, perhaps less stable or focused on other priorities like colonial expansion, using existing, refined sailing ship technology, or internal consolidation, might not have provided the necessary infrastructure or legal framework to support large-scale, centralized industrial enterprises. Whatever the precise combination, scientific timing, resource availability, technological feasibility, socio-political resistance, the rapid, widespread shift to fossil fuel-powered industrial production and the factory system didn't occur on the scale seen in our timeline for centuries. Humanity continued to develop, driven by curiosity and ingenuity, but along different technological and economic paths, building upon existing foundations. Focus shifted to refining and expanding energy sources used for millennia, now approached with scientific rigor. Water power, the workhorse of pre-industrial economies, was revolutionized through far more efficient turbine designs and harnessed on an unprecedented scale through vast, interconnected canal systems and strategically placed reservoirs. Wind power, traditionally used for sailing and mills, saw the development of elegant, towering structures with aerodynamically optimized blades, culminating in the ubiquitous turbines of 2025. Later, as scientific understanding progressed differently, humanity began to harness solar energy, perhaps through different collection and storage technologies adapted to decentralized use or integrated into regional grids in sun-rich areas. Human and animal power remained significant for local transport and agriculture, potentially leading to advanced selective breeding or innovative ergonomic technologies. Production, rather than consolidating into vast factories, relied more heavily on highly skilled craftspeople in smaller, specialized workshops, utilizing advanced tools and materials that enhanced their capabilities without requiring massive capital investment in centralized machinery. Or it evolved into sophisticated decentralized networks of specialized production units, where components were manufactured in different locations, each perhaps powered by local renewable energy sources, and then assembled elsewhere, managed by intricate logistics systems. Automation developed as a progression of tool use and system optimization, but often focused on augmenting human skill, precision machinery guided by skilled hands, automated looms managed by expert weavers, or robotic arms assisting in assembly in a smaller workshop setting. Crucially, automation also focused heavily on managing complex systems for resource distribution, balancing energy flow across grids, coordinating transport networks, or managing supply chains for decentralized networks, rather than primarily replacing human labor entirely in centralized mass production facilities. Chemistry evolved as a science, but without the immediate push from the petrochemical industry and the need to process vast amounts of coal tar and crude oil. Its focus lay elsewhere, perhaps on biological processes like fermentation and biosynthesis for materials and chemicals, sustainable extraction methods for natural resources, or novel materials science based on minerals, ceramics, and advanced composites derived from sustainable sources. The consequences were profound. Without the explosion of mass-produced, relatively cheap goods and rapid, chaotic industrial urbanization, class divisions were less sharp. Social structures might have retained more elements of earlier systems based on inherited status, land ownership, though land management would differ, or systems based on skill, craft mastery, or control over regional renewable energy sources and their associated infrastructure. Urbanization was potentially slower, more organic, or more dispersed, its growth centers determined more by access to reliable renewable energy sources and favorable environmental conditions rather than proximity to coalfields. One might find bustling port cities leveraging tidal power, communities flourishing along waterways powered by hydro turbines, settlements expanding in wind corridors, or new cities emerging in sun-drenched regions centered around solar collection arrays. Global trade occurred, facilitating the exchange of high-value goods, specialized components, and resources that could be transported efficiently using alternative methods like advanced sailing ships, some potentially augmented by electric or pneumatic power, efficient electric trains, or perhaps more extensive use of large airships for slower, heavier cargo or comfortable passenger travel. Environmental challenges were also different in nature and scale. While localized pollution existed from workshops or waste disposal, the global-scale atmospheric pollution, widespread acid rain, and the cumulative buildup of greenhouse gases driving rapid climate change, hallmarks of widespread fossil fuel burning, did not emerge as the dominant, existential global threat. Environmental concerns existed, focused more intensely on protecting river purity, managing the impact of large-scale infrastructure projects like dams or wind farms on local ecosystems, or addressing localized air quality issues from specific industrial processes. The global ecological footprint was fundamentally different. By 2025, Earth was undoubtedly a technologically advanced world, capable of incredible feats of engineering, communication, and connectivity, but its modernity felt distinct, shaped fundamentally by the path not taken. Its landscapes were marked by the visible infrastructure of renewable energy, vast offshore wind farms, intricate networks of river and tidal power generators integrated seamlessly with natural waterways, sprawling solar collection arrays in sun-rich regions often designed with aesthetic considerations, and carefully managed forests and agricultural zones for food, timber, biomass energy, and carbon sequestration. Cities, while large and densely populated in key areas, might feel more integrated with their environment, designed with efficient resource use and waste cycling, often blending living spaces with decentralized production units, workshops, vertical farms, and accessible green spaces. Transport systems across this world were generally quieter and potentially slower over vast distances than in a fossil fuel-dominated world, but they were highly efficient and reliable within their parameters. They relied on advanced electric trains running on regional or continental grids, high-tech sailing ships, some augmented, efficient electric road vehicles charged at distributed points, and perhaps more extensive and sophisticated use of airships for slower, heavier cargo or comfortable, scenic long-distance passenger travel. Technology was advanced, but specialized. Materials science excelled in areas crucial for renewable energy, storage, and decentralized production: lightweight, durable composites for turbine blades and vehicles, advanced ceramics for high-efficiency engines and insulators, and biomaterials derived from sustainable sources for construction, textiles, packaging, and chemicals. Energy storage technology, whether advanced solid-state batteries, sophisticated kinetic storage systems, like massive flywheels, or novel chemical solutions, was highly developed, a critical necessity for managing the inherent intermittency of wind and solar power and ensuring grid stability. Automation existed, but worked in conjunction with skilled human operators, augmenting their precision and strength, or managing the complex logistics of decentralized networks and the vast, dynamic grid. Biological engineering might have advanced significantly in areas like optimizing biomass efficiency, developing new crops, or perhaps even creating specialized biological systems for waste processing or atmospheric regulation. Scientific inquiry pursued different avenues, shaped by available energy sources and materials, potentially leading to deeper understanding of biological processes, fluid dynamics, atmospheric science, vital for weather prediction and energy forecasting, and materials science based on sustainable resources. Our story focuses on Anya Sharma, a system manager for the Pan-European Wind and Water Network, PWWN, a vast, multinational entity overseeing a complex, integrated grid powered primarily by wind farms, river turbines, and tidal generators across the continent. Anya's control center, located in an energy-efficient building powered by a nearby river wherein seamlessly integrated into the regional grid, was a hub of activity. Its walls were covered with vast, interactive holographic displays showing real-time energy output from thousands of generators, dynamic grid load maps displaying consumption patterns across thousands of kilometers, intricate, constantly updating weather patterns influencing wind speed and water flow, and sophisticated demand forecasts calculated by advanced AI models processing trillions of data points. Anya ran a hand through her short, practical haircut, her eyes scanning the complex holographic displays. This wasn't just a job, it was a vocation, a deeply felt responsibility. Growing up in a remote mountain village that had once faced crippling energy shortages every winter before grid integration, enduring weeks of darkness and limited communication, she understood what stable power meant. It wasn't just convenience, it was survival, connection, the very rhythm of daily life. Now, she was one of the people who kept that vital rhythm beating. Her work was critical. It involved the constant, delicate act of balancing the intermittent nature of some renewable sources with the constant, fluctuating demand from millions of homes, transport systems, and decentralized production units. This meant predicting shifts in generation hours in advance, rerouting power flows dynamically, coordinating maintenance schedules, and making critical decisions in moments of unexpected crisis, a profoundly complex task requiring not only sophisticated AI assistance but also constant, experienced human oversight, judgment, and the ability to interpret anomalies the AI might miss. One morning, as the pale February light filtered through the control center's energy-gathering windows, the comfortable hum of the system shifted, subtly at first, then punctuated by sharp, insistent tones. A series of urgent alerts began to flash across Anya's primary holographic display, the red warnings spreading like a rash across the continental map. Her breath hitched slightly. Unusually low wind speeds across multiple major wind corridors simultaneously, coupled with significantly reduced water flow in several key river systems feeding major hydroelectric installations, due to unforeseen upstream events, perhaps a sudden frost snap or unusually low winter precipitation her initial models hadn't fully captured, was creating a critical, widespread energy deficit. And worse, a critical research facility located deep within the affected zone, the Pan-European Bioaeronautics Lab, working on next-generation atmospheric control systems vital for predicting and managing global weather patterns, and thus improving energy forecasting, was showing dangerously low power reserves, its internal buffers depleting rapidly, just hours away from a potential cascade failure that could halt decades of irreplaceable critical data collection and analysis. Grid reserves, the carefully maintained buffers of stored energy, were dropping rapidly, the holographic bars representing them shrinking before her eyes like sand in an hourglass. Anya felt the familiar surge of adrenaline, sharper now, laced with a cold dread for the lab, for the millions in the affected cities, for the potential ripple effects. Her training and years of experience took over. Initiate Level 3 grid balancing protocols, she instructed her AI assistant, its interface sharpening. Her fingers flew across the console, confirming parameters. Prioritize core urban and critical infrastructure nodes, hospitals, communication hubs, grid control substations, essential transport lines. Her voice tightened. Maintain power to the Pan-European Bioaeronautics Lab. That data is irreplaceable. Reroute reserves if necessary. Activate all available biomass and geothermal backup plants in the affected region. Issue public advisories continent-wide for non-essential consumption reduction, starting with the most affected zones. The AI processed commands instantaneously. Maps shifted, power flows adjusted, backup plant indicators changed. But the deficit was larger than anticipated, wider and deeper than typical fluctuations. A younger operator, Kale, face pale with urgency, pointed. "Anya, Sector 5 is dipping dangerously low already. Faster than the model predicted." "I see it, Kale." "Reroute auxiliary power from Sector 4, immediate priority on essential services there," Anya responded, voice steady despite the knot in her stomach. She glanced at Ilara, her senior operator, whose calm demeanor anchored the room. Ilara met her gaze, a silent acknowledgement of severity, her fingers already moving, initiating the specific reroute. A communication window opened, displaying Raj, a regional manager. His usual calm replaced by tight worry. Behind him, automated trams sat idle. "Anya, we're seeing significant impact already," Raj reported, voice strained. "Distributed production units across the city are slowing, some halting critical processes, water purification, food synthesis labs reducing output. Our local battery buffers are depleting faster, demand is higher because the cold snap is increasing heating needs. Transport networks severely strained, overhead line vehicles queuing, charging stations struggling. And reports, localized civil unrest near the docks. People are frustrated, cold, unable to get to work or access necessities." Civil unrest. The word jolted Anya. This wasn't just technical, it touched the fragile social contract built on grid reliability. "We're diverting everything we can, Raj," she said, projecting confidence. "All available biomass and geothermal are online. Coordinating with adjacent networks, but they're near capacity, some facing similar issues. This isn't localized, it's widespread environmental impact. And Raj, the Bioaeronautics Lab's work on forecasting is vital for preventing crises like this. We must keep them online." Raj nodded grimly. "Understood about the lab. We'll manage what we can here. Emergency services are deployed. Just keep us informed, Anya. Let us know the moment you have a clearer timeline or if we need to initiate deeper local shutdowns." The window closed, leaving Anya with the weight of his plea and the stark reality outside. Managing this crisis was a complex dance with natural systems, human expectations, and the grid. It required deep, real-time understanding of meteorology, hydrology, geology, and the grid's demands. It was a constant negotiation with the unpredictable power of nature. Displays pulsed with data showing demand spiking, highlighting the delicate balance. The control center's hum felt charged. Kale sighed, frustrated. "It's like everything's conspiring." Ilara placed a calming hand on his arm without looking away. The crisis deepened over the next few hours, a slow-motion cascade. Reports detailed impacts, intercity rail halted or on reduced schedules, disrupting supply chains for decentralized production components. Material transfer systems frozen, creating bottlenecks. Non-essential services offline, public lighting dimmed, buildings shut down, commercial hubs quieted. News feeds showed frustrated citizens, makeshift pedal-powered chargers, dark workshops. Anya felt the accumulated weight, a physical ache. She had ordered rolling consumption reductions, prioritizing residential areas and essential services, acknowledging inevitable disruption. Advisories went out, urging conservation, a plea for collective responsibility. Response was largely cooperative, a testament to societal norms, but the shortfall was too significant. "Status update on inter-network transfers?" Anya asked again, voice tight. "Adjacent networks providing maximum possible transfer based on limits and conditions," Ilara reported, voice flat with exhaustion. "PEWWN north slightly better wind, PEWWN East stronger hydro, but both lower solar. PUN South strong solar, minimal hydro. No significant help to bridge this gap in real-time capacity. We are drawing what we can, but it's a trickle against a torrent. Interconnectedness was strength, but a large-scale anomaly strained the system. Anya initiated Phase 2 advisories, explaining the uncertain recovery timeframe based on latest forecasts. She emphasized community resilience, asking neighbors to check on each other, those with local backup to share power. Work with regional coordinators, Ilara, she instructed, to identify critical local needs the automated system might miss, isolated medical facilities on depleting battery backups, emergency shelters needing heat, anything. This required cross-referencing grid data with local reports from secondary channels. For hours, the control center was a hive of intense, focused activity. Anya directed micro-adjustments, rerouting critical lines, coordinating with maintenance, anticipating stressed substations and equipment failures. Her gaze constantly swept displays, tracking thousands of points, identifying potential failure points. She authorized a temporary, small power reduction even to parts of the bioaeronautics lab, a calculated, agonizing risk based on their internal storage and necessity of keeping core data servers running. "It's a gamble," she murmured, watching the lab's reserves dip, "but fresh water is non-negotiable. A city cannot go without water purification." Power diverted from less critical sections of the lab was rerouted to prevent a critical municipal water pump station failing in a densely populated area reporting pressure drops. Kale was managing communications with emergency services, relaying where power was stable enough for charging emergency vehicles or command centers. His earlier fear morphed into grim determination, voice crisp as he relayed info, though hands still occasionally trembled. Ilara, ever steady, coordinated with maintenance crews and local grid operators, troubleshooting localized issues, ensuring backup biomass and geothermal ran efficiently, managing fuel and glitches under strain. A temporary setback occurred when a major biomass plant reported a critical fault, a sensor malfunction from the load shift. Ilara calmly guided the local team through emergency protocols, rerouting output while they worked to bring it back online, adding complexity. Then, localized blackouts flickered in a rural area, a cascade failure from a struggling substation. Anya immediately directed a team to assess, prioritizing restoring power to medical facilities or shelters using portable units or local generators. "Reports from Raj are getting worse," Kale said, voice tight. "The unrest is spreading. Security forces are managing, but they're asking if transport to key distribution hubs can be restored sooner. People need supplies." Anya swallowed, air thick. "Tell him, we're doing everything we can. Prioritizing critical services, then transport lines serving essential infrastructure. It's a delicate balance, Kale. Too much too fast, and we risk overloading again." She watched the lab's reserves. Still dipping, but slower. Holding. Slowly, almost imperceptibly, the tide turned. On displays, green lines for wind power in western corridors thickened. A small, shy increase, then growing steadily, confirming forecasts. Southern solar output peaked, a green beacon. The red deficit narrowed. Wind speeds increasing, sectors 7 through 12, Ilara announced, relief in her voice, shoulders relaxing. Generation capacity restoring in major western wind farms. Models showing sustained increase. Anya felt exhaustion, suppressed. "Begin restoring power, least critical zones first," she ordered, voice sharp. "Stagger restoration to avoid spikes. Prioritize areas with longest outage. Maintain advisories, encourage conservation. We need to build reserves." She watched the lab's reserves climb as power was restored. The gamble paid off. Core systems remained online. Hours later, as the sun set, casting long shadows across the valley of the Great Wind, grid indicators showed near normal operation. Reserves were low, some localized challenges remained, but the immediate crisis passed. Demand met, albeit with less buffer. Power reductions lifted systematically. Anya leaned back, tension draining, leaving deep weariness. Ilara and Kale looked drained, but shared relief was palpable. They navigated the storm of absence. Faced the challenge inherent to their path, vulnerability from relying on natural cycles, and overcame it by understanding, adapting, managing themselves and technology with nature's capabilities. Looking at turbines, silent rotation as symbol of recovery, Anya felt quiet accomplishment shared with her team. Their world, built on enduring forces, a testament to different ingenuity, rooted in observation, adaptation, sustainable practice. Crisis, a stark reminder of integration and vulnerability, but also resilience, distributed nature, source diversity, sophisticated management. Society's cooperative spirit from understanding energy comes directly from environment. The quiet revolution shaped a different Earth, grappling with distinct challenges, realizing a different potential, powered by clean, renewable, sometimes unpredictable, pulsive planet. As displays showed stable green lines and building reserves, Anya closed her eyes. Their work, a constant negotiation, continuous adaptation, quiet custodianship of balance between humanity's needs and nature's power. Test met. Turbines continued silent dance, symbol of energy sustaining civilization. Full recovery would take time, transport needed full restart, decentralized production backlogs, reserves rebuilt, consequences of unrest addressed. But lights were on. Lab data stream stable. System held. Later, as night shift arrived, Anya, Ilara, Kale gathered near quiet console. Ilara brought warm mugs. Rough shift, boss, she said, voice rough with fatigue, sitting heavily. Kale, slumped, managed weak, tired smile. Thought we were going dark there for a bit. For real dark. Anya managed tired smile back, briefly touching their arms. Almost. Good work, both of you. Everyone in the chain. Raj and his teams, maintenance crews, everyone. That was too close. She sipped hot drink, warmth spreading, small comfort after cold dread. Distant city lights steadily coming back online on holographic map, tiny points appearing one by one, then in clusters, powered by silent giants, rushing rivers, captured sunlight they served. Work never finished, negotiation never over. But tonight, they proved world's unique resilience.